All right. Now, if I seem excited for this next section, it's because I am. This is my favorite part of statistics, where I talk about the normal curve. The first thing I want to tell you about the normal curve is it doesn't always look the same. Depending on the variance, these three curves are all normal, but they have decreasing amounts of variance as you go from fatter to thinner. So here's a normal curve with little variance, here's one with a medium amount of variance, and here's a normal curve with a great deal of variance. And things to remember about the normal curve are they are symmetrical around the mean, they're unimodal, which means that they just have one most commonly occurring value. And I'll just interject right now, a bimodal curve would look like this. See how it looks like a camel a little bit? Because there are two modes, right there and right there. And here is the mean, and here is the median on this. But with a normal curve, the mean equals the median equals the mode. They're all the same in a normal curve. The next slide I want to show you guys is really fun. And just take a look at this, and you'll see that what I've done is I've sliced up a normal curve with a number of lines. Each line indicates a standard deviation from the mean. Okay? And I thought I'd get us started with this conversation by talking about the IQ test, the WACE IQ test. And as I'm sure most of you know, or all of you know, that the mean of the IQ test is 100 and the standard deviation is 15. So that if somebody has a score of 115, we know that they're here on the normal curve. If they have a score of 145, they're over there. And what's great about the normal curve is if you are able to put someone on the normal curve, you can then compare them to other people in the sample or the population that the curve is based upon. The way to do that would be to look at the percentile associated with their score. Let's just take, for example, that someone has an IQ score of 130. You might ask, well, what's the significance of that? If someone has a WACE IQ score of 130, that puts them right here in the normal curve, which means that they are at the 98th percentile amongst others who have taken that test. Which means if they're in a room with 100 people drawn from that same sample or that same population, they will be smarter than 98 of them. Boy, I hate it when people don't turn off their cell phones when they're supposed to be working. Okay, I'm silencing that now. Okay, so, all right. So this is for IQ scores. Then another way to talk about somebody's score on a normal curve is to put it on the T-scale, give them a T-score. The T-scale is structured so that the mean is 50 and the standard deviation is 10. Now ask yourself, what test do we use that uses T-scores? There's actually more than one, but the most common one would be, of course, the MMPI-2, which has, on every scale, a T-score of 50 would indicate that the person is average. And for every 10 that they go away from the mean, they're going one standard deviation up or down. So let's say that somebody has a T-score of 65 on scale 4, for example, the psychopathic deviant scale. Now notice that a T-score of 65 falls right here. I don't have the exact number for what this cuts off, but if you think about what's going on in the normal curve, what you'll say is, okay, we know that 84% of the population has a t-score below 60, okay? Because this is 50% on that side of the mean and 50% on this side. So 50% plus 34% means 84% have a t-score below 60. And this slice has 14% of the people in it. And if you're over here, then you're cutting off more than half of 14%. So let's just call it 10%. And what that tells us then is that a t-score of 65 would correspond to the 95th percentile. So when we're to get a t-score of 65 on scale 4 of the MMPI, what we know about them is that they are substantially different than the population when it comes to that domain that's being looked at by scale 4. Okay, now the other part of this that you've been acquainted with already, but I'm just going to reiterate it, is something called z-scores. Z-scores are just standardized scores like the IQ score or like the t-score for the MMPI, but the standardization is on a different scale. And z-scores are calculated so that the mean is equal to 0, and each standard deviation is a z-score of 1 away from the mean. So we have 0, then 1, then 2, and then 3. And as we go to the left of the mean, -1, -2, and -3. Now, I hope that it's clear from this graph that you can go from z-scores to percentiles very easily. If someone has a z-score, for example, on the comp exam of 0, that's actually pretty good. That means that they were average in their class. If they have a z-score of 1, that means they're at the 84th percentile. And conversely, if someone has a z-score of -2, then they're at the 22nd percentile. So that's what I wanted to say about the normal curve and about transforming. You can transform, if you know the mean and the standard deviation of responses on any test, you can transform each individual score to a z-score, and that will instantly allow you to compare that person to the rest of the people who took that test, which is a very useful thing to be able to do.